It's 13. A person is standing 40 feet from a flagpole, and you can see the top of the pole at a 35-degree angle of elevation. The person's eye level is 4 feet from the ground. This is critical. And there's a lot of times in math classes and science classes, there are things that we like to kind of negate or leave out or not have to worry about. And the idea is this. Let's think about, let's say I'm trying to find the height. Let's say that this is Mount Everest. Okay? So that's Mount Everest, and I'm down here. Okay? And I know how far away I am from the base of Mount Everest. And I can determine the angle of elevation to be, I don't know, let's say just 50 degrees, whatever, I don't know. And I'm able to find, using that information, I'm able to find that height right there, right? Okay. The fact that I've done everything from my feet, it gives me a number back. Okay. I don't know how tall Mount Everest is, but let's say it gives a pretty large number back. Okay. Is the fact that my eyes are maybe 5.5 feet off the ground a really big deal in regards to how tall Mount Everest really is? No. Okay. Well, my eyes aren't right at the top of my head. Okay. Does that make sense, everybody? Okay. So sometimes we interpret from kind of the ground or feet the height of something. But when I'm talking about a flagpole, thinking about, flagpole, they're 30 feet tall, 40 feet tall, something like that. Now, the height from the ground to my eyes is something that is not negligible. Something it's pretty large value in comparison to the total height of the flagpole. Does that make sense, everybody?
Yes.
So and in that type of situation, we want to incorporate that. So, here's our flagpole, right? We know that we are 40 feet away from it. Okay. We are standing, okay, and our eyes are, let's say, 4 feet above the ground. Absolutely. No, it doesn't make a difference. My line of sight normally, okay, and the way we kind of talked about this yesterday, is that if you were to look straight ahead of you, your line of sight is going to be parallel to the horizon, right? Parallel to this 40 feet horizontal. So we know that dotted line is 40 feet. The angle of elevation, guys, is the angle that line of sight that is parallel to the horizon needs to change so that it becomes your line of sight, and you can see the top of your flagpole. Okay? So that angle right there is your angle of elevation. Is that okay with everybody?
Yes.
All right, so they're saying that is 35 degrees. Okay? Now, in this figure, we see the right triangle here. We're going to have the ability to find that red segment. Okay? But is that red segment the length of my flagpole?
No.
No, it's only a part of it. Okay? So I'm going to call that y, and we're going to go through the work here. It says tangent of 35, because y is opposite, right? 40 is adjacent, so that's why I chose tangent. But we'll say y over 40. So you get 40 tangent of 35 is equal to y. So we'll type that in, see what we get. See a lot of people, when they're talking to me over questions, they're getting them wrong because they're forgetting to change their calculator into degrees. Always keep that in mind. So I get that number right there. So that's 28. So 28 is that red distance. Okay? What is the height of my flagpole then? 28 plus 4, so 32, right? Okay? That idea is because the reason I want to talk about this and add that 4 in, because if I don't, okay, 4 divided by 32, okay, it's 12% of my flagpole's height, right? So I don't want to leave that out. All right? We don't want to make the assumption that these angle of elevations are coming from the ground and not our eyes, because we need 12.5% of our flagpole's height out of the equation.
At lunch, my best friend had an error.
That's good.
Protein.
Protein for you, yeah. All right, so that was what, 13? Let's do. Did you say you wanted to see 14? 14? All right. You guys know what a vole is? Yeah.
Yeah, I know, like a void. Isn't that like the divots? Drop quiet.
Yeah, it's some type of rodent.
Yeah. A void?
Vole.
Oh, void.
All right, so an eagle's perched up in a tree. Okay, so our eagle's up here. Okay. Again, it's perched up 40 feet up in the tree. So that height right there is 40 feet. It's looking down here at a vole. So there is your line of sight from the eagle. But it says it looks down at a 35-degree angle. Okay? So it doesn't use the word angle of depression, but that's what it's talking about here. So the eagle normally, with eyesight parallel to the ground, to look at the vole, it needs to take that line and rotate it down 35 degrees. Does that make sense?
Yeah.
So that's 35 degrees. So if that's 35 degrees, what is that?
35 degrees.
35 degrees, because this line here we hope to be parallel to that one, or we want to be parallel to that one. So now we've got this right triangle here where we have 35 degrees and we have 40 feet. We should be able to find either that distance and or that distance. Okay? Which one is this referring to? It says, how far is the vole from the eagle? Is it looking for X or is it looking for H? It's looking for H. It wants kind of that direct distance when we talk about the length the eagle basically would have to fly to get to the vole. Because if I found this X value, that is not the length that the eagle would have to travel to get to the vole, right? Does that make sense, everybody? So with that, they're with their terminology and their verbiage here, they're asking for that distance there. So what trig ratio would I use here in this triangle?
So you have the hypotenuse and opposite,
Yeah, so I'm going to, which is the sine, right? So say sine of 35 is equal to opposite over hypotenuse.
Would you give us that for the test? Yeah, flip-flop.
So we flip-flop them and we'll get H is equal to 40 divided by sine of 35.
Will you give us that on the test?
Okay. I'll give you what?
So
As a question, yes.
as like a phrase.
No. All right, so about 70 feet there. Okay. I'm not going to give you on the test this phrase here. Okay. But there will be a question that asks you the sine is a comparison of what side divided by what side? OH. And then cosine is AH. And then tangent is OA, right? So it'll ask you in some format that. Hopefully you get that right, but then later on in other questions, if you can't remember what it was, could you go back, say that's question 3, could you go back to question 3, reference it? If you missed it, then tough luck on the rest of them, but write them on your arm. There you go. That won't get you in trouble.
The one time we were thinking about this, and I had my phone right next to me, but then I put it away. Because I forgot. Oh snap. He just submitted the cheating on test. If I was cheating, why would I say something? And I thought Mr. Perry was gonna yell, and I was like, oh, can't do that. I forgot to do it. Send it on the office right now, it's cheating. Automatic suspension. Yeah, Carter, we were taking a test together. Shut up. I said, Carter, I can't see your screen. And you're like, alright, yeah, throw your friend, or something like that. Why that may be true.
I know it's true. I hear you.
Shut up, I never said that.
Yes.
My iPhone did it.
All right.
I hear you.
Airplane is flying altitude of 10,000 feet. Airport at which it's scheduled to land is 50 miles away. Find the average angle at which the airplane must descend. Okay, so when it says descend, that's the same thing as angle of depression. Round your answer to the nearest degree. So, we got our airport down here.
Is it gonna matter that there's different
Yes, that's a huge component. That's why I want to show this question. That's a huge component.
Change miles to feet then.
So we got plane here,
Okay.
okay? And the plane is flying at a current altitude of 10,000 feet, okay? The airport is 50 miles away. The plane is going to descend to obviously get to your airport, right? It needs to know what that angle of descent needs to be. So our angle of descent, again, is your angle of depression. So we need to put in that horizontal there at the airplane and talk about that as being your angle of descent. Does that make sense? Or your angle of depression. And they're saying that is what we're looking for. So I just call it theta. Is that the same as that angle right there?
Yeah, exact beta.
So I'm going to call that, well, they're the same, so I'm going to call them both theta. Okay? What side? So if I want to find that, so I'm finding an angle, now I'm going to have to use either my sine inverse. Right. So we got to use one of these things, but we use still the same ratios as SOHCAHTOA defined. So this is the opposite side, and this is the adjacent side, right? So I'm going to say that the tangent of the angle theta is equal to the opposite side, 10,000 feet, divided by the adjacent side of 50 miles. Okay? Now, and we talked about this in Chapter 7, the first section, Chapter 7. If you have two distances, okay, or two measurements that can be converted to the same unit, you want to do that. Okay? Otherwise, things are going to be off. All right? So we're obviously going to take tangent inverse of both sides. Okay? And it's going to look something like this, tangent inverse. Now, I need to change one of these to the other unit. So feet to miles or miles to feet. And ultimately does not matter. But what one is the most logical? Miles to feet. How many feet are in a mile?
5,280.
Okay. So the reason I think, now the numbers are larger, but the reason I think that is more logical is because when I multiply 50 by 5,280, both of those are integers, so their product is going to be an integer, 264,000. That's an integer, okay? It's a really nice number, correct? Okay? If I changed 10,000 feet to miles, that's going to give me like I think it's like 893,939, something like that. It gives me a kind of an ugly decimal, all right? Where this is just better to deal with. All right, now you don't have to do this, but I'm going to reduce. Do these both have a factor of 1,000 in them? So that 1,000 on top and that 1,000 on the bottom kind of wipe each other out, right? They're a factor of 1. So I'm going to type that in. And then there's still a factor of 2 in both those if you want to factor that out. But we're going to type in tangent inverse, and that's just using arc. I don't like to find that function over here, so I just type in arc tangent. It's faster. 10 divided by 264. Okay, and it gives me 2.169 degrees. Okay, if you left it as 10,000 divided by 264,000, it still give me the same number. Okay, if you went down to it's 5 divided by 132, it's still the same number.
Yes, sir.
Yeah. Okay. So that's the angle of descent that you need. Now, if you changed everything to miles, okay, so 10,000 feet divided by 5,280 feet, that will give me 1.8939393939 miles. Does that make sense? So I could still take arc tangent of that, but now everything would be in miles. So I'll take that number, paste it, divide by 50 miles. Does it still give me 2.169? So that kind of shows you that you can either do both units in feet or both units in miles. Okay. Now I don't like this number because I had to round it. What's nice about Desmos is that you could do this. You knew that number is equivalent to what? How did I get that number? Right, so I could actually type that in right there. And now there's absolutely no rounding being done, right? Does that kind of make sense to everybody? So if you want to do that, those things are awesome. If you can learn that logic and it's essentially that algebra, it's going to increase your algebra skills and your competencies in using technology to help you find exact answer, really accurate answer. Because, okay, so the question is, how do I know when to use that, or that, right? Okay. Here's what. First of all, is ask this question: if I take arctangent of 10 divided by 264, that gives me that answer right there, correct?
Yeah.
If I take tangent inverse of 10 divided by 264 using that notation, is it the same number? Is it the same
Yes, it is.
decimal? So that tells me that these two things, tan inverse and arctangent, are actually the same thing. It's just a different way of talking about it, okay? So use whatever version of that you want, okay? So that implies tangent inverse. This implies cosine inverse. This implies sine inverse. Now, I know to use that type of function when I'm looking for an angle. So there in that problem, we were interested in, let me get back to it, we were interested in finding the angle. So that's why I knew that I had to use that grouping of ratios, the inverses. Does that make sense? Now, how did I know which one of those to choose? Is that the question?
Talking about like how do you know like whether to do inverse, like tangent inverse or just regular tangent?
Okay, so if I'm looking at these are for looking or finding an angle. Okay, and that's what we're looking for here, right? We're looking for that angle of descent. The other ones, so sine, cosine, tangent, those are when I'm looking for a distance or length. Okay, but they're either version. I still decide which of the three to choose based off of SOHCAHTOA, right? Why did I use tangent inverse on that one? Because I have information on the opposite side and the adjacent side, and that's TOA. So that's why I use tangent inverse. Looking for an angle, and those are the parts that I was given for in respect to that angle. Did that answer your question? All right, so I think was there any others that you guys want to talk about? Any? So that was 20. Anybody need anything else?
No.
We're good?
Yeah.
Okay.